guys, today we're on lesson 11.2 and we're going to start with task 1. Alright, so yesterday we looked at exponential growth and now we're going to look at exponential decay functions. An exponential function of the form f of x equals ab to the x power, where a and b are real numbers and a is greater than 0 and b is between 0 and 1, is called exponential decay. The parameter a is the value of f of x when x equals 0 and also the y-intercept of the graph. The parameter b is the base of the exponential function. Alright, so exponential function you've seen, remember, a is going to be your y-intercept, b is your base, and when it's between 0 and 1, it's exponential decay. So that is important. That's basically your definition of exponential decay function. Alright, so it says consider the exponential function f of x equals 1/2 to the x power. Alright, so you can see the base is between 0 and 1, so we know this is an exponential decay function. You can create a table of values and use the points generated to create a graph. So we've got our x and our f of x. Remember, f of x is our y, so our x and our y, so these are just ordered pairs. And when we plug in our x values to our function, so we've got 1/2 to the x, so 1/2 to the -3, 1/2 to the -2, 1/2 to the -1, and so on. You can see what points that generates. So our f of x, our y value, comes from plugging in the x value into the function. So our points would be -3, 8, and if we come down here, they've already graphed this, so we got -3, 8, and then -2, 4. So -2, 4. You can see this is 5, 10, 15, 20. And then -1, 2, -1, 2, and then 0, 1, 1, 1/2, 2, 1/4, and 3 and 1/8. So you can see now it is going down and getting very close to 0. So this is called an exponential decay function because it's decaying very quickly. Before, remember, our function would rise, and that was our exponential growth function. Alright, as in the previous lesson, the x values chosen in the table are integers. Like exponential growth functions, exponential decay functions are defined for all real numbers. Based on the table, how is f of x related to f of x minus 1? Alright, so it's related to f of x minus 1. Remember, this is the function f of x equals 1/2 to the x power. So it's going to be f of x equals 1/2 to the x minus 1. Alright, and it says compare the value of f of x from the table. The first is 8, the second is 4. So you can see 4 is half of 8, 2 is half of 4, and so on. So that's where the half comes in. Each value is half of the value before it. And it says this makes sense because the base of the exponential function is 1/2. Alright, based on the table, how is f of x related to f of x plus 1? Alright, so this is going to switch it. So now it's going to be twice if you go in the other direction. If you go in one direction, 8, 4, 2, you're half in those numbers. But if you add 1 to x, then it goes up. So each value is twice the value after it. Okay, so that makes sense because the exponential function is 1/2 and the multiplication or the multiplicative inverse of 1/2 is 2. Okay, and again, this is the difference between going in one direction, x minus 1. That means you're subtracting 1 from your x, and this means we're going the other direction, we're adding 1. Alright, explain the relationship between f of x and f of x minus 1. Choose the expression that completes each equation. Alright, so f of x minus 1 is going to be 1/2 to the x minus 1 power. Remember, when this is in parentheses, that's affecting your h value. And if it were outside the parentheses, it would affect the k value. Your h value in this case is the exponent part. All right, so then we have f of x minus 1 equals. All right, remember properties of exponents. We got the same base when we're adding exponents. So this is just another way to rewrite this. So all it did was break apart. We put the same base with both parts of the exponent. And then now they're just going to evaluate. So 1/2 to the negative 1 power, remember that flips the base, so that would be 2 to the first power. So the first part stays the same, times 2. And then that is 1/2 f of x minus 1. Remember, we're using the base, and the minus 1 came from the 1/2, half in the value in front of it. And 1/2 f of x minus 1 equals f of x now. All right, it says on a piece of paper, try using the laws of exponents to find the relationship between f of x and f of x plus 1. Okay, we're going to go through the same process, and we're just going to go ahead and reveal these. If you want to pause the video and work on it first, you may do so, but it's going to be the same process. It's going to take 1/2 to the x plus 1, separate the base, raise it to both parts of the exponent, and then 1/2 to the first power is just 1/2. And then that would be 2f of x plus 1 equals f of x. All right, so here you would have to do the multiplicative inverse, and that's where that's where it changes from 1/2 to 2, because this is the y, f of x times 1/2. All right, complete the table by finding the indicated values of f of x. Some decimals are rounded to 3 places. All right, so remember you've got 1/2 raised to this power. Okay, if you don't want to do that mentally, you can use your calculator. So here it's going to be 2 to the 5th power, because again it's a negative exponent, so you would flip the base. So it'd be 2 over 1. 2 over 1 to the 5th power is 32, but you could also do 2 to the 5th if you're not sure that that's 32. All right, 1/2 to the 1/2 power. Okay, as a fraction, that would be 1 to the 1/2, and it would be 2 to the 1/2. 1 to any power is just 1, but 2 to the 1/2, let's see what that's going to be. So we're going to have 1/2 raised to the 1/2 power. And that's going to be 0.707. So that's going to be this one. And then we're going to say f of square root of 2. So 1/2 raised to the square root of 2. May not need parentheses here. Let's see. And then square root of 2 is on this side. And these calculators can be very handy because even a math teacher is not going to know what 1/2 to the square root of 2 is. So that's going to give us 0.375. I would know it's between 1 and 2, but I wouldn't know exactly what it is. All right, so moving on, it says complete the equations. All right, so we've got 1/2 to the 10th. Okay, so let's see. So it's going to be 1/2. Okay, let's see. 1 to any power is just 1. So what's 2 to the 10th power? All right, so it's going to be 1 over 1024. And 100 is going to be 1 over 2 raised to the 100. Very large number. Let's see what our choices are here. All right, they just leave it in exponential form. So 1 to any power is 1, and 2 to the 100 power, probably the same thing here. All right, so remember you do your numerator and your denominator to the same power. All right, will the value of the function ever reach 0? The answer to that is no, because there's an isotope. It's going to approach 0. It's going to get very, very close, but it's not going to get to 0. So a positive number raised to any exponent is always positive. All right, which statements about exponential growth functions and exponential decay functions are true? Select all that apply. The graph of both functions have x-intercepts. That's not true because it doesn't cross the x-axis. The graph of both functions have a y-intercept. That is true. The functions have the same domain and range. That's true. The domain of an exponential function is the range of an exponential decay and vice versa. That's not necessarily true. Both functions have a horizontal isotope. That's true. Both functions approach 0 for a large value of x. That's not necessarily true. Exponential decay functions approach 0 as x increases without bound, while exponential growth functions approach positive infinity. All right, so this is talking about in behavior. Exponential decay, we know that it's a curve and it's coming down. This says a function approaches 0 as x goes to the right, and that is true. All right, exponential growth is always increasing, while exponential decay is always decreasing. That's true as well, because exponential growth is a curve that goes up. Exponential decay is a curve that goes down. So that one is also true. So that one has 5 correct answers. All right, that is all for task 1. If you have any questions, please let me know.